Good afternoon, dear students. In this session, we will discuss about chemical properties of alkali metals. In the previous class, we already discussed distinctive properties of lithium, uses of alkali metals. So, in the beginning of this unit, you learned about the physical properties of alkali metals. Physical properties like electronic configuration, ionization enthalpy, electronegativity, oxidation number, atomic and ionic radii, hydration enthalpy, flame color and spectra. These are the physical properties of alkali metals. And the next one, chemical properties of alkali metal. It is explaining the reactivity of alkali metals, how it is reacting with oxygen, with the hydrogen and halogens. It may be with the water, liquid ammonia. Okay, so generally, alkali metals are reactive metals. They have high reactivity. So, they are chemically reactive. Okay, high chemical reactive. They have high chemical reactivity. So this reactivity of the metal is increasing from top to bottom of the group 1. So top to bottom of the group, how it is increasing? From lithium to cesium, it is increasing. Okay, so now the reactivity is increasing with going down to the atom, down to the group 1. So the reactivity is increasing from lithium to cesium. Their ionization energy of this alkali metals are decreasing. So ionization energy is decreases with increasing reactivity. Okay, all the alkali groups are electropositive compounds, so they are highly react with electronegative compounds like halogens, oxygen and nitrogen. Electropositive alkali metals highly reactive with electronegative compound. So this reactivity of this alkali metals are explaining below with the reaction. First one, reaction with oxygen. When treating all the alkali metals with the oxygen, or it is exposed in oxygen or air, the reaction between alkali metals and with the oxygen is a vigorously burning reaction. So it is one explosive reaction. When alkali is exposed on the into the air, it is a violent reaction. So they react violently. They can form oxide of the particular alkali metal on their surface. So if lithium is reacting with the oxygen, they can form only monoxide. So lithium can form only monoxide. If sodium is reacting with the oxygen, they can form monoxide and peroxides. Monoxides and peroxides. Then all the metal from alkali metals, they can form monoxide, peroxide and superoxides. Peroxides and superoxide. Okay, superoxide. So the reaction of alkali metals with oxygen, 4 molecules of lithium reacting or it is exposed into the air, it form only monoxide. That means it form only the simple oxide like 2Li2O. This is lithium oxide. So they can form only simple oxide. Monoxide means simple oxide. Lithium oxide. And the formation of sodium peroxide, 2 molecules of sodium reacted with the oxygen, they form Na2O2. So what is the name of this compound? This is sodium peroxide. So sodium can form oxide, that means simple oxides, and also can form peroxide, but they can't form the superoxides. All the metals can react with the oxygen and form monoxide, peroxides and superoxides. So the reaction for that metal is reacting with oxygen, they form superoxides. Okay, superoxide. So metal can be potassium, rubidium, cesium. Okay, because lithium and sodium can form they are the different case, they can't form superoxide. That's why the formation of superoxide with a metal, it's only happen in potassium, rubidium and cesium. Then the next reaction with next chemical property, reaction with hydrogen. Reaction with hydrogen. All the alkali metals can react with the hydrogen at above the temperature 673 Kelvin. But lithium, all metal, this is for all the metal. But the exception case, lithium at 1073 Kelvin. They can form ionic hydrides. We know that the reactivity is increasing from lithium to cesium for all the metal. But when the alkali metals are reactive with the hydrogen, it is decreasing their reactivity with the hydrogen from lithium to cesium. So lithium to cesium reactivity is decreasing. With hydrogen. Okay, so with the hydrogen reaction. Reaction for alkali metals reacting with hydrogen is 2 molecules of metal combined with hydrogen molecule. They form hydrides, ionic hydrides. So ionic hydride means they can form plus and minus compound. So the combination of ions in the product is known as ionic hydrides. So hydride means hydrogen. So hydride, we know that the symbol of hydride is minus. In the reaction, the ionization character of the hydrides ionization character is increasing. Ionization character is increasing, but the reactivity is decreasing from lithium to cesium. But when they form the product ionic hydride, so comparing this ionic hydride from lithium to cesium, the ionic hydride is increasing from lithium to cesium. So when they increasing their ionic character from lithium to cesium, also they decreasing their stability. So increasing ionic character with decreasing their stability. So these hydrides are behave as a strong reducing agent because of their reducing nature. Their reducing nature is increasing down to the group. Next property, third chemical property, reaction with halogens. Reaction with halogens. Say what are the halogens you have? Halogens we denoted by X: fluorine, chlorine, bromine, iodine. Okay. Alkali metals are readily combined with the halogen to form the ionic halides. Ionic halides like Mx. M is denoting metal. So what are the metal are present in alkali metals? Lithium, sodium, potassium, rubidium and cesium. So alkali metals are readily combined with the halogens and they can form the ionic halides. Ionic halides denoted by Mx. The reaction between this alkali metals and halogens are increasing from top to bottom of the group because of the decreasing ionization enthalpy. So increasing the reactivity with decreasing ionization enthalpy when they react them. Alkali metals are reacting with the halogens. Two molecules of metal reacting with one molecule of halogen. 2 moles of metal is reacting with one molecule of halogen. They form 2mx. This 2mx is ionic halides, which is the combination of alkali metal and halogen. All the metal halide which is formed because of this reaction are ionic crystals. The metal halides are ionic crystals. From these ionic crystals, lithium iodide, this is also one ionic crystal, but they show the covalent character. Why it show the covalent character? Because of the smaller size of the lithium. That means smallest cation is existing in this lithium iodide, and they exert the high polarizing power of this iodide ion. So when the formation of lithium iodide, lithium is positive, iodine is negative. So lithium is a electropositive compound, or it is a cation. Iodine is electronegative compound or it is anion. So the electropositive compound contain their size is less. So the smaller size cation, because of this smaller size of this lithium ion, and the iodine is existing the high polarization power of this anion. So this lithium iodide shows covalent character. So you can say this lithium cation is smaller one, iodine is a high, it has this ionization, atomic radii is larger than the lithium. Next chemical property is reaction with the liquid ammonia. Alkali metals are dissolved in the liquid ammonia, and they give the deep blue solution of that reaction, and they are conducting nature. Alkali metals with the liquid ammonia. So the metals are dissolved. They dissolved in liquid ammonia, and they form the product solutions like deep blue color solution. So this solution have the capability to conduct the electricity through this solution. So the conductivity of this deep blue color solution is similar with the conductivity of the current through the pure substance, like the alkali metals, the pure alkali metals. So the conductivity power of that pure alkali metal is similar with the conductivity nature of this alkali metal dissolved in liquid ammonia, which resultant of deep blue color. So the specific conductivity of this mercury is the pure metal, right? Pure one. So the mercury is 10 power 4 ohm power minus 1. And the sodium is dissolved in liquid ammonia solution. Their conductivity, specific conductivity is 0.5 into 10 power 4 ohm power minus 1. So why it has happened? Why this liquid ammonia solution is conducting the electricity like the pure elements? Because of the alkali metals have their loose electron, one loosely bound electron in the valence shell. So the readily moving electron from the valence shell of alkali metals is dissolving in the ammonia solution. So because of this character, the conductivity is similar. So the dissolving reaction of alkali in the liquid ammonia, this reaction is giving here ammoniated electrons, that means ammoniated anions and ammoniated cations. Ammoniated cation means the alkali metals which is dissolved in this liquid ammonia solution. So they can form ammoniated cations. Like ammoniated cation means this alkali metals in liquid ammonia, and ammoniated anion, that means the released electron from the valence shell of alkali metal is dissolving in the liquid ammonia. So the reaction for this above reaction equation is metal, alkali metal with X plus Y, the amount of ammonia. Okay, the number of moles of ammonia reacting with metal, and they can form metal ammoniated compound. Okay, so ammoniated cation. Metal means that is metal cation. So the alkali metals are electropositive compounds. This combined with the metal, and they formed here ammoniated cation plus formed ammoniated anion or ammoniated electron. So what is ammoniated electron? Ammonia is combined with the electron which is released from alkali metal. So this is ammoniated anion. So when dissolving this alkali metals in liquid ammonia solution, they become deep blue color because of this ammoniated electron is absorbing energy from the visible region of light. So the light is given in the visible region. That light is absorbed by the ammoniated electron. From this ammoniated electron is absorbing the light from the visible region, and because of this absorbing reaction, it's produced the blue color into the solution. So this generally the solution is a paramagnetic solution, and they can liberate the hydrogen with slowly, and they resulting the formation of amides. So when the paramagnetic solution of this paramagnetic solution is liberating the hydrogen slowly, and they result amide as a result. So the reaction for this amide formation solution, first amide formation, this ammoniated cation, that is denoted here M plus, this ammoniated cation, and ammoniated anion in the ammonium solution, they form amide NH2. M is metal, NH2 plus releasing hydrogen. Okay, releasing or liberating hydrogen. So it is liberating as a gas, hydrogen. When treating this more concentrated solution, or treating this alkali metals more into the, or dissolving this alkali metals more amount into this ammonia solution, then the solution will become more concentrated with dissolving increasing amount of alkali metals. So the concentrated solution generally they are diamagnetic. Why? Because of this more concentrated alkali present in this liquid ammonia solution, this deep blue color will change into the bronze color. So because of this color change, coloration change, this solution is behave as a diamagnetic solution. Fifth chemical property of this alkali metals are reaction with water. Reaction with water. When treating alkali metals with water, this alkali metals is react with water, and they give hydroxide with liberating the hydrogen, with evolves the hydrogen from that solution, they form hydroxide. For example, 2 moles of lithium is combined with 2 molecules of H2O. 2 moles of H2O is produce lithium hydroxide. 2 moles of lithium hydroxide with liberating hydrogen. 2 lithium and 2 H2O. From that 2 lithium is combined with 2 OH and they form 2 LiOH, and the remaining from that 4 hydrogen, 2 hydrogen is combined with this lithium and oxygen. So the remaining 2 hydrogen is liberated as a hydrogen gas. Alkali metals also can react with the alcohols and alkynes. So they can react with the alcohols and also with the alkynes. The reaction example for this alcohol reaction, 2Na 2 C2H5OH. They produced here 2 C2H5ONA. So which is liberating? Hydrogen is liberating. H2 is liberating from this solution. You can see this reaction. 2Na is combined with C2H5O. This hydrogen is removed from this alcohol, and in the place of hydrogen substituted with the sodium. So already you have 2C2H5O, and this 2 is combined with the C2H5O, and it's become C2H5ONA, and the released hydrogen, 2 hydrogen is released or liberated as a hydrogen gas. Then the sodium can react with the alkyne. Sodium can react with the alkyne. So the alkyne, for example for this alkyne is ethane. Okay, ethane. What is the formula of ethane? CH triple bond CH. So CH triple bond CH. This is treating with the alkali metal like sodium. So the sodium is replaced one hydrogen from the carbon, and they substituting in the place of that hydrogen, and it will become H, this H bond C triple bond, this triple bond, then carbon, it's already there. So carbon single bond, then the sodium is substituting in the place of hydrogen. So hydrogen in the place of hydrogen, sodium is substituting. So which is removing? It's removed hydrogen. Okay, it's removed hydrogen. So the minus, if they put the minus and some compound, this is removed from there. Okay, then again treat this with the sodium. Again it is treating with the sodium, or it is reacting with the sodium. Now what will happen? The sodium is replacing the hydrogen in the another end of this alkyne, and it's substituting in the place of hydrogen. So this will become, this hydrogen is removed by sodium. So Na single bond C triple bond C single bond Na, and it's liberated here of H2. So hydrogen is liberated. So the next property is reducing activity. Reducing activity. Sixth property, reducing activity. So alkali metals can lose their valence electron readily because they are loosely bound electrons, so they can easily removed from the valence cell of that alkali metals, and because of this character they can act as a good reducing reagent. Okay, good reducing agent. So the reaction for this formation of good reducing agent, metal solid state, metal in the solid state. Metal means the alkali metals, and they can form M plus. Why it form M plus in the gaseous state? Because of releasing one electron. Now this metal is behave as a reducing agent. So the final property, chemical property of this alkali metal, reaction with carbon. Reaction with carbon. In the distinctive property, we already learned about the reaction of carbon with the lithium and other metals. Lithium can directly react with the carbon and they can form the ionic compound. But other metals are not directly react with the carbon, but they can form the they can react with the carbon compounds like acetylene, and they can form acetylides. So the reaction for this lithium carbide formation, 2Li with the 2 carbon, reacting with the 2 carbon, they form Li2C2. This is known as lithium carbide. So they have the capacity, only lithium is reacting with the carbon directly, not other alkali metals. So this session is completed today. Thank you, students.